So hi everyone, we're starting this live demo that we've been planning out for a while now. So my name is Enzo. From Dental Tech Expert. We're here with Brian Lee from Amann Girrbach and Rebecca from Garland Dental. And our idea today is to give you an idea of the basics of a full arch, fully digital workflow. So I'll start. Let me just share my screen with you all here. Well, just before I start, why don't you two just quickly present so everyone knows who are we talking to?
Right. Hi, everybody. I'm Rebecca Sarago. I'm with Garland Dental Services. If you haven't heard of us before, we're out of Texas. We are both a distributor and a service company for equipment in the dental industry.
Perfect.
Hi, I'm Brian Lee with Amann Girrbach. I've been with Amann Girrbach for 12 and a half years as a trainer, and now I'm a demo specialist for demos to sell equipment and to teach people about our equipment.
Perfect. So the basics that we're going to cover today. First of all, I'm going to be handling the first part of this presentation. I'm going to do the full arch workflow in terms of stages and technologies available. After I finish, Brian is going to take in and he's going to show you guys how this actually looks in a day-to-day, in a real lab, in a real clinic. And Rebecca is going to finish it off, just basically talking about the investments and what do you actually have to put on the table to be able to have something like that. So let me go ahead, and this is a quick workflow overview. So what we have here are all the stages needed on a full arch digital workflow. And on the bottom, what you're going to be able to see are the technologies that you need for each stage. So first you have digital impression, where you can have intraoral scanner and photogrammetry. Then you have designs with CAD softwares, design softwares, nesting with CAM softwares. Production, you have printing and milling. We are going to discuss a little bit about the difference between those two. Sintering and finishing with two different ovens. And that's really important for us all to understand. Most of you know, some of you might not know. So those are two separate ovens. So let's start to talk a little bit about the digital impression. And just a disclaimer or a reminder here, I'm not going to go too deep into each technology. It's going to be a general overview and a couple tips on what you have to think about when you are choosing such an equipment. So starting with digital impression, and we're going to focus on full arches, right? This whole thing that we're building today is about full arches. So we're not going to talk about over teeth or single implants, all full arches. So here you have basically three options. You have your traditional intraoral scanners, you have photogrammetry, and lately we've been hearing a lot about grammetry. So what kind of equipment do you need to do each one of those cases, each one of those options, let's call it. So with an intraoral scanner and the grammetry, you're going to use your scanner, your basic intraoral scanner. It can be any scanner you're going to be able to scan with those two. And photogrammetry, if you're talking about real photogrammetry, nowadays you have mainly two options. Either you use an extraoral equipment like a PIC camera, an iMetric, a Micron Visioneer. There are a couple different options out there. And you would still need an intraoral scanner. But how to choose, like, which one is better, which one is best, what kind of solution should you look for in terms for your clinic, for your lab? There is no doubt that the gold standard in terms of accuracy, precision for full arches is photogrammetry. The problem, it might not be affordable for everyone. That's where grammetry comes to part. Because remember, with grammetry, you use exactly the same equipment you were using with intraoral scanner. The only thing you choose are the scan body. You start to use these horizontal scan bodies. And just to be really quick, maybe too technical, the reason why these horizontal scan bodies exist is because with the regular scan, it's really easy for the scanner to lose reference when it's between one scan body and the other, and then you lose accuracy. So that's why you have the horizontal scan bodies to kind of fill out this gap. This is a really simple, really basic explanation, but I think it gives you guys an idea of the differences. Now, 4 things to look for or to think about when you're deciding which technology you use for digital impression. First of all, of course, budget. If you're not limited on budget, I would strongly recommend that you do use photogrammetry. If you're not, maybe look for a grammetry option. There are a bunch out there. Accuracy is important. And this is something that I don't think we pay close attention to. Um, just think about, let's say you have the best designer in the world, the best ceramist in the world, the best mill in the world, the best sintering oven. You have everything, the best of the best. But if the scan is not right, the whole thing is based on a false information, and you're not going to get the right result. So the scanner is the basis, is the foundation of your full arch workflow. So that's why it's really important for you to consider the right technology when you're buying this, when you're starting your full arch workflow. Number 3, integration. You need to buy a scanner, a photogrammetry, whatever it is, that integrates with what you're going to be using afterwards in terms of design, cam, whatever it is. And ergonomics is also important. You're going to be using this day in, day out, so it has to be comfortable for you at the end of the day. Now, let's talk a little bit about design. I know many of you want to learn how to design, and if we were here to teach you how to design, we could probably spend 4 days just talking about that. So what I'm going to say, what I'm going to talk about are the real basics of a design software, okay? So here we have 3 options, probably the 3 most common options. You have Exocad. Amann Girrbach has its own Exocad version, which is called Mind. They're the same base. So anyone that knows how to handle Exocad is going to know how to handle Mind. It's that easy. Then on the other end here, you have 3Shape. It's probably the 2nd most common design software out there. And then on the middle here, you have a software called Blender. Blender became a really big thing because of the eye bars. Basically, you design a full arch and you take part of that full arch and you transform it into a bar. That software became huge in the industry basically because it's really easy to do that on that software. All software works. All software can design great restorations. All software can do pretty much everything you need. What I think are your key decision points? Number 1, is it easy to find a technician that knows how to deal with that software? So if you're looking for, if you have Exocad or Serum in mind, I can guarantee you 95% of the designers out there know how to handle Exocad or Serum in mind. If you're doing Blender, maybe less, maybe 15, 20, 30%. So I think that should be your number 1 concern when deciding the design software. It has to be easy to find someone to handle it for you. Number 2, can they do, remember, we're talking about full arches. So can they do arch and bar in one step? So you don't have to design a bar, scan the bar, and then design the full arch. I think that's a really time-saving, and it actually delivers more accuracy to the whole workflow because you're not adding a second scan to the process. Number 3, does it have enough libraries? So are you going to be able to use the implants that you use? I know the great majorities are going to use MUAs, but we have different MUAs from different brands, from different sizes, different heights. Does that software carry the implants libraries necessary for what you're using? And as always, for integration. Integration is a huge thing, and it's one of the things that I really like about the whole Amann Girrbach workflow. It integrates really well. It makes it really easy to use. Now, let's talk about nesting. Just before we talk about nesting, I just want to explain what it is in a really simple way. On the design software, after you finish, you're going to have a 3D file, an STL file of your full arch, the bar, whatever it is. The nesting part is where you're going to take that file, place it in the blank, puck, disk, whatever you call it, and put the disk to mill. That's the nesting software. And you have basically 2 options. There are a lot of different brands out there, but they're going to come down to 2 types. You have open, and I'm not going to say closed like it's written here. I'm going to say semi-closed, right? So what is the difference between open and closed? To be clear here, both you can use whatever material you want, and you can import cases from whatever design software that you want. That's not what open and closed mean. The main thing behind the closed and the open is the ability to mess or to customize the milling strategies themselves. So if we talk about open cams, what are the advantages? You have more flexibility, they're customizable, you can get quick upgrades if you have the tech with enough experience, and you have off the shelf strategies that you can buy not from the manufacturer to use on your mill. What are the disadvantages? You have a longer learning curve. And this is just a phrase here: with great power comes great responsibility. So when you have the power to deal with the power to customize your mill, to make it go faster, make it go more aggressive, make it use smaller bursts, you can also damage your mill. So you need to have a lot of experience to work with open cams. So who is this for? Experienced user, high volume, high complexity operations, for those who need the most out of the equipment and have people to handle it. So if you don't have someone to really take care of the mill, someone that is really experienced, I would stick with the closed one. Why? Because it's a controlled workflow. It's really easy to use. They have ready to go strategies for all the major materials out there. The disadvantages, it might be a little bit slower to upgrade with new materials, with new strategies. You have limited tools. So the tools you have available are the tools that you're going to be able to use. Does that mean that you're not going to be able to do one case or other because of the lack of tools? Probably not. In 99.8% of cases, you're going to be able to use the tools available out there. And you are manufacturer dependent. That is true. You depend on the manufacturer to deploy new strategies. So who is this for? Anyone without a lot of experience in milling, not in digital dentistry, in milling itself, small scale operations, or for those who need simplicity and something that just works. So you need to place a file there, click a button, choose one or two parameters, and hit go. And you're assured that at the end, you're going to have your full arch. Maybe 20, 30 minutes slower than what you would in an open mill, but you don't have the hassle, you don't have the risk of working with a closed system. Just a quick reminder, if you guys have any questions during this live, you can just type it. You have the chat there. You can type it. We'll have people answering that chat throughout the whole live. So back to the presentation. What are the 4 things that we have to look for or to think about when we're deciding which nesting software we're going to work with? First of all, level of experience. So who's going to be handling? Do they have knowledge? Do they know how to handle that? Or are you going to use maybe an assistant, maybe a designer to handle that? Number 2, level of complexity. So if you're doing bars and you need to screw things down on the bar, you need to make the threads, all that, maybe go for an open. Now, if you're doing just basic full arches, really well planned implants, yeah, maybe a closed will work fine. Number 3, ease of use. And you'll see integration is a big thing for everything because you have to have an easy workflow. Now let's talk about production, milling and printing and milling. I'm going to focus more on milling, but first let's talk about the differences. And I'm not going to talk about the technical differences between milling and printing. I'm going to talk about the application differences. So what are you going to be able to do with a 3D printer? To be really, maybe to oversimplify, when you have a printer, you're basically looking at provisional workflow, right? You can do surgical guides, you can do bite splints, you can do quick try-ins, maybe short-term provisionals. Now, when you go to milling, you can still do provisionals in PMMA, maybe some ceramic-loaded PMMA with multi-layer, which adds a lot of aesthetic to it. But you can also go for final cases. So as you see here, depending on the mill that you use, you can do even a TI bar, a titanium bar with a zirconia overstructure on the same mill. And talking about mill, there are a lot of different options, but when we're talking about zirconia, about full arches themselves, we're going to focus on 2 types. And they're going to depend on the type of full arch that you want to do. If you want to do a full zirconia, you can use a 5-axis dry only mill like the Motion 3 Air. We're going to talk a little bit more about them. That's the one that Brian has on his background over there. And if you want to do zirconia with a TI bar, you need a wet and dry mill, but not any wet and dry mill. It's not every hybrid mill that is able to properly handle titanium milling. So the Matron would be the perfect choice inside the Amann Girrbach portfolio. Why? Because it was honestly built for that. I can spend another hour just talking about the technicalities of what makes the Matron the perfect mill for metal, but I just chose 4 items here. Number one is this VMAX arm. VMAX because it's in a V shape. Basically, what this does, it gives stiffness during the milling process. The main thing you have to control when milling is vibration. So when you have this arm here, you're going to control a lot of the vibration. You reduce a lot of that. It is the only mill in the market with that kind of technology. Number two, you have optimized blank holder, and the metal holders, they have this, I think this is called the zero clamp system. Am I right, Brian?
Yeah.
So the metal holders, they have a bigger clamp here. And again, this is all to control vibration, to control the whole, like to give more accuracy to the milling. Oh, there you go.
Yeah, that's the base. That's the base for the clamping mechanism there.
There you go. You have a robust and weight optimized cast aluminum body with rigid axis. Again, what is that mill? I'm not going to get too technical here, but just understand this mill was built for this. It has a one-piece body that, again, is focused on reducing vibration. And you have flexibility to change between 3 and 6 millimeter shank. So you have thicker burrs when you're milling titanium, and maybe you have another burr when you're milling zirconia. So again, all to control vibration. This is the whole point of when you're buying a mill that is able to do metal, you have to be able to control vibration. There it is. Brian has it on the screen. Brian, I think you have to speak to be able to pop up on the screen.
Oh, okay. So these are the 2 different shanks, 3 millimeter and a 6 millimeter for milling metal.
Yeah. So we don't have to be like mechanical engineers or anything just to realize that thicker means more stable, thinner means less stable. So that's why you need thicker burrs when you're milling titanium. Now, when we talk about production, if you're doing full arches, the very first thing you have to ask yourself is, what do you want to do? Do you want to do just full zirconia? Do you want to do zirconia with titanium milling? The second question is, what do you want to outsource? Maybe you're not in the budget for a titanium milling mill, so maybe you're going to start outsourcing the TI bar and milling the zirconia in-house. That's why you have to figure out what outsourcing, what do you want to outsource first? And I think this is what Rebecca does really well. This kind of not consultation, this customization of each reality to know what makes sense for each customer. So maybe you need to outsource bars, maybe you need to outsource maybe the arches, and you just need a printer. At the end of the day, each quote is going to be specific for each customer. Ease of use, it's always a big thing, especially if you're a small operation, if you don't have a lot of people to handle, if you're an office, if you're a clinic, it has to be something easy to use, easy to maintain. And as always, integration is a huge key point for the whole workflow. Sorry, Rebecca, Brian, do you have anything to say here? Let's just keep it somehow dynamic.
I just like to say for anyone who's watching, Enzo is an incredible wealth of knowledge. So if you guys have questions and you need some guidance and you want some help on what to do, what's best, please reach out to him. I get a lot of information myself from him, so please use him as a resource.
I wasn't expecting that, Brian. Thank you. Let's talk about sintering and finishing. I said that in the beginning, and I get that question quite a lot. And yes, we're talking about 2 different ovens. There are ovens in the market that can do both in one, sinter and the glazing, but they're not for full arches, right? our focus here today is to talk about full arch. Am I wrong here, Rebecca? Or am I saying there are options that can do both or not?
There are, and it's not something I would recommend.
There we go. So let's just stick with the reality that we're talking about two different ovens, one for sintering, one for standing glaze. Standing glaze, stacking ceramics, whatever your finishing option is, okay? So what is important when you're talking about a sintering oven? I'd say those four are the main things that define define what a good oven is. First of all, the max temperature, and just to really maybe too technical here, you need the maximum temperature is important because the translucency and the aesthetic part of the zirconia is given when you hit the max temperature of that zirconia sintering cycle. That's correct, right?
Yes.
Okay, just making sure. So that's why it's important to have an oven that reaches, let's say, at least 1500, maybe 1550 degrees to be able to accommodate the most amount of zirconia options out there. Temperature accuracy, I said plus or minus 1 degree, but there's no really way to measure that precisely. But just imagine, when you reach the high temperature, you can't have an oven that keeps varying or the temperature fluctuating, because the characteristics are not going, you're not going to reach the right color, you're not going to reach the right translucency, you're not going to reach the right aesthetics if the temperatures keep varying when you reach the top. So you need an oven that reaches and maintains that accurately. Heat distribution, this sounds kind of obvious, but we have to talk about it. The distribution inside the sintering chamber has to be uniform. You can't have 1500 degrees on the top and 1100 on the bottom. I'm saying random numbers here, but I think you guys get the idea. And the chamber size, it has to fit at least one full arch, any size of full arch. And depending on the case, depending on the production, you might find ovens that fit 2, 3. I don't know if there are ovens that you can fit 4. Probably yes. But you have to figure out what oven fits your production level. Again, I think this is something that at Garland they do really well. Kind of fit whatever your reality is to the quote that you're getting. When we talk about the standing glaze, again, it kind of goes the same way. It has to have accurately, it doesn't necessarily mean low temperature, but it has to reach a certain temperature and it has to keep that temperature. Remember, those ovens, whatever it's sintering or standing glaze, they have heating cycles that are really specific. The more accurate you are with that heating cycle, the better your final result's going to be. And that depends on the material, on the heating elements. It depends on a lot of things, and you have to talk to some specialists to really figure out what the differences are. So that's why you have maybe $2,500 ovens and $15,000 ovens. There are a lot of differences there. So now I think I've talked a lot. We've covered the basics of the workflow. Now Brian is gonna take it from here. And what he's gonna be showing is we're gonna pretend on our demo here that we have the scanning and designing ready. So just so we kind of play something here, Brian is a lab tech, whether he is inside a clinic, whether he is inside a lab, and he got the designs ready from the designs, and he's going to put it to mill. Brian, I think you can take it from here.
All right.
You can show your screen. I'm going to close mine. There you go. You should be good.
All right. So what I'm going to show today is everything's good.
Yes, sir.
Okay. So I'm basically going to show you the workflow of how to produce the full arch cases in the AG system. So I'm going to showcase a little bit about, kind of the things that we have. So I will start with registering a puck. So this is something that we have here at Amann Girrbach, where if you use our materials, you can see my screen. So what I'm going to do here is I'm going to add a blank, and I'm going to register a new puck with this scanner. So I'm going to scan. Okay, so you can see here that if you're used to using CAM softwares and doing this, you know the process of registering a puck. Every time you have to do it, you have to enter the shade, the size, the shrinkage factor. All of this data needs to be entered for every puck. Well, with our scanners and our puck materials, you can quickly scan it, and you can see in here the lot number comes in, the shrinkage code comes in, the shade. All we have to do here is select a name. We just call this Enzo. Enzo, this is a 20 millimeter Bion A2. We have A2 already, but we can still put it right. All right, so easy, quick to register your materials. And then from here, I'm going to import, and I'm going to import this from my downloads. I'm going to import, for example, the Waxup, which is the zirconia. So the case comes in, and we can, maybe I picked too small a puck, but let's see. I'm going to unlock and rotate this. Okay, and now here, now in our system, you can create and mill your full arches just with the full arch, or you can do them with a stabilizer. Okay, you can do it either way in our system. This is a kind of a weird thing, but I've talked to a lot of people about which way is best with stabilizer and without, and it's 50-50. Some people say, I've done hundreds of units without the stabilizer, everything is fine. I've talked to other people who say, you absolutely have to do stabilizers. I'm not here to tell you how to do it or which way is better. I'm here to tell you, you can do it however you want to do it. So if you want to use a stabilizer, you can. If you don't, you don't have to. And then in addition to that, you can see here, we have the C-clamp holder. So if I show the frame in a motion 3, which is behind me here, the motion 3, you can see that the C-clamp has a certain radius where you have the open area to mill. If I switch this to the Matron, because of the heavy, wide base being more stable, you can see that in the Matron, if I use the C-clamp holder, the C opens wider. Because the mill is more stable, it's able to go wider, and this is what allows you to now, let's lock that.
Brian,
Rotate this.
just for the sake of information, and for those who don't know milling at all, can you explain for us the difference between the milling difference you have on a closed versus a C-clamp holder?
So I have something here to show you. Basically, with the C-clamp, it will basically allow you to mill at a 90 degree. So if you're milling a puck normally like this, you are normally milling from this direction and not this direction. Obviously, because the holder is there, you would be going through the arm, and the C-clamp opens up this way, which allows the mill to now come in at this angle. And now you have, previously, before without the C-clamp, you have all this detail in the CEJ area of this restoration that's designed perfectly, and then the mill can't get to it. And now you have this design software creating something so nice, but now you have to come to the bench and carve it by hand, which who wants to do that, right? So basically the C-clamp opens it up, and one of the benefits to having the wider C-clamp here is that now you can get all the way down to the first molar. Whereas in the Motion 3, you can only maybe get to maybe around the first premolar. So this is definitely a big advantage to using the Matron, giving access to a wider area.
Nice.
Okay, then obviously from here, you would change the connectors, remove the facial ones. I'll give you guys just some tips here that I've learned kind of along the way over the years. And I've seen people that have problems with breakages when they're sintering. And a lot of times what we'll see is something like this, where more connectors is not better. Somehow it causes movement. So actually, and I've talked to a lot of friends in the industry who are doing this every day. They're saying, 5 or 6 on the lingual is plenty. Okay, do not over sprue your lingual connectors. Okay, and then from here, you run the calculation. It goes to the mill. Yep, Enzo.
Brent, just one thing that you showed, and I think it's interesting to mention. Just turn the blank around and just show the shades. I think it's important for people to understand that you can actually see the gradient of color when you have a multi-layer blank. This is a 20 millimeter, so it's really tight on the blank there. But let's say you have a bigger blank, a 25, maybe a 30 millimeter, and you can play around a little bit with those colors if you want to, depending on the case. And I think that's really interesting. Maybe you don't have the right color on stock and you need a case ASAP. You can maybe play a little bit with the height in case you need to.
Yeah, and just to clarify, we have the puck that I'm using here is a 20 millimeter, but we also have 20 and we also have 30. Now the 30 and the 25, the shade of this A2, the shade actually starts from here and ends at the half mark. So it's not A2 from the top of the puck to all the way to the bottom, because most of the time when you're doing these full arches, the bottom half is gingiva.
Yep.
And so because the gingiva takes up the bottom half, the A2 or A1, whatever shade it is, starts from the middle and ends at the halfway point. And this is for the 30 millimeter and the 25 millimeter pucks. Okay.
Nice.
All right. So now when we go next, I would just want to show you guys a couple of features in our CAM software. And that is number one, to show the simulation results. Okay. This is, anyone who does full arch cases knows that it's important to know what the simulation shows you in terms of like problem areas, or there are certain areas in the restoration that it will not mill out. So this is important to have. If you're milling, I know we're on full arches, but let's say we're milling 15 single unit crowns. Okay, if you're milling 10 single unit crowns, we have something called reduced tool changes. And what that means is, normally in a normal production mode, you pick up tool 1, cuts crown 1, picks up tool 2, mills restoration 1, picks up tool 3, mills restoration 1, and then starts the process all over again, milling 10, 15 units. When you hit reduce tool changes, then what that does is it takes tool 1, cuts crown 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then picks up tool 2, mills crown 1 to the 4. And what that does is it speeds up the process of milling several units instead of spending a lot of time changing tools. So that is a feature that we have in here. For one single arch, one case, this button doesn't matter. But for milling multiple units, it is important because everyone wants to mill faster. So,
Brent, let me just
What
go forward
kind
with
of
that.
time savings is realized by reducing the tool change?
I haven't done one, but maybe we can do one and I can post and we can share that with the group. Like, I'll do 10 units. We'll do one without a tool change and one with. I don't have to mill it. We can just run the calculations and we can post a time that shows the difference between the two. That's a good question.
That's a good one.
Okay, now fissures. Fissures are the occlusal surfaces of posterior teeth. So fissures will not apply to anteriors, but if you wanted to do the standard mode means that we have a 0.6 millimeter burr that will cut the occlusal surface. And if you go to HD mode, we have a 0.3 millimeter burr. It looks like a needle that will cut the occlusal anatomy, much more detail, but of course you're adding 5 to 10 minutes per unit, depending on the size of the unit. And then with the margin, you can also select which tool will cut the margin areas.
It
All right.
follows the same logic, right? Standard 0.6, HD 0.3.
1 millimeter, 0.6.
1 millimeter, 0.6. Okay.
Yeah. Okay. And then the implant parts are not showing because it's not the bar, right? So, okay. So we run this. I'll tell you guys, I can share with you guys, this is not a direct to implant. This is over a bar. So what I can share with you guys is I took pictures.
Brian, while you take the pictures, I'll just ask you one question that I get asked a lot. If I use this blank and I don't have to use it for another 2 or 3 days, I can just go there, pull the blank on the system. It's going to have the milled out area, and I just place the other cases, right?
Yeah. So if you look at my library here, my library of blanks that have previously been used, you can see that any partial blank stays in here. You can select that one, bring it back in, and then use the area that hasn't been used.
Perfect.
So I know people are going to ask, so what was the milling time for this particular case? It was 3 hours and 13 minutes.
3 hours. That's really good.
Standard mode. Okay, not HD mode. HD mode would probably be closer to 4.5 to 5 hours, right? Because you have a 0.3 burr cutting all that detail all the way around that arch. So both options are available, basically. Okay, do we want to see the bar?
Yeah, I think it's fair. Let's just look at the bar.
All right, so let's just open up a second one here. And we will import the bar that was used for this case. All right, so we're going to import the bar. And we're going to, let's do, just for time, this bar actually is a 20 millimeter. This bar actually will fit into a 13.5 millimeter, but close that. And now, when you're milling titanium, I don't know if this is an Amann Girrbach thing or if this is just a standard practice for milling metal, is that with zirconia, you can have overlap. You can have overlap where the crowns are overlapping each other and the mill can go from milling air into milling zirconia. But when it comes to milling metal, you don't want to have something like this, where you have an area that's overlapping, because what the mill does is it mills a material that's very hard, that's resisting, and then you come into an area where there's nothing there, and then the spindle goes up, and then it comes into an area and then could create crashes or more vibration or damaging of the tools. So our philosophy at Amann Girrbach is to say, look, do not overlap and have a smooth transition milling with a better final product. So when we're nesting this, I would go to the connector. I would only put 2 connectors on the areas of where the abutments are, because obviously this is the fit. This is the more important part of the fit, where you want stability in the areas where the implants are. I've talked to several people who say they just do 1 bar on the lingual. So I'm not going to say one way is better or the other, but I get it. If you can have 1 thick bar on the lingual and less to finish. That's an option. You can change the diameter of your sprues. You can do partial cutoffs. So what I've done here is I've changed the diameter down to 1 millimeter and chose to put one on the buccal, one on the lingual. But of course, if you want to put like this one here, you can put a thicker sprue on the lingual and not have anything on the buccal. So you can do it either way. Okay, then from here, when we hit next, there's a few other options in this. Again, simulation of the milling results is important. Reducing tool changes, we're not going to do that. Now, the abutment type, this is important. So for the abutment type, you have 3 different selections or 3 different options here. The tie connect means that you're going to mill this with the plan to cement a multi-unit abutment to the restoration, and that is what sits on the patient's interface. Most people obviously don't do that because our mills are capable of milling them. So instead, we would normally select multi-unit abutment, meaning this is going to be the seat which sits on the patient's implant. And because we have flat tools, we can now come in here and mill a flat seat here for the screw to sit onto. And depending on what libraries you use, there are also other options if you want to do a Rosen screw or Powerball to have a not flat screw seat. So all of these options are available, not for this library that was used, but in other libraries that I've seen, there are those options to have the Rosen screws and Powerball. And then the abutment fit, this is kind of a nice feature. Yeah, go
Brian,
ahead.
can you just go back on the other option there, the abutment type one? Just open it up.
Yep.
Just so I get this right. So the first one is, let's think about the levels, right? You have implant, you have multi-unit, and you have a metal cap, right?
Yeah.
So the first option there, TI Connect, you're going over this metal cap, right?
Yes, over a tie base.
Over a tie base, perfect. So you're going over a tie base. Now you take the tie base off, you go to the second option. You're doing over the multi-unit, right?
Correct.
And the third option that you have there, implant level, is you're not even going on the multi-unit, you're going down on the implant level. If that's recommended or not, if that's clinically right or not, it's a different conversation. I just want to understand the options there.
Yeah, so implant level, again, like you said, goes into the implant. So if you guys are a laboratory and you want to follow FDA guidelines, that is technically not legal. You can do it. You can have tinted windows, but you can get a ticket for it, right? You can do it, but legally, that's up to you. Now, we can mill abutments. I've tried them. Pretty fun, pretty cool. Not legal. I didn't sell it, so it's okay. But you have the option to do both, right? And then
as a doctor, are you able to do it? Are you allowed to do it as a doctor?
I would consult the FDA. Yeah.
Perfect.
As I understand it, as a doctor, the FDA cannot tell a doctor what to do in his own practice. But if a doctor makes it for another doctor, now you're fall under those rules, guidelines.
Okay, so don't trust us. Go after that information yourselves, please.
Yes. Yeah. Trust us. Yeah. Well, we'll tell you when to trust us. So
yeah.
Abutment fit. This is also a very nice feature that we have in our CAM software that I've heard doesn't exist in others, which is if you are going to mill a screw retain crown, if you're going to mill a screw retain crown like this, and you're going to buy a tie base, and you're going to cement your crown to the tie base, this is an additional die spacer setting that you can adjust if you want to make them tighter or looser, totally separate from the implant libraries that you're getting from the companies. So this is a nice thing where you can make it tighter or looser to fit onto the tie base. And then
multi-units, Brian, what would you recommend for, like, when you have a bar like this and you have multi-units, then you need the passive fit, and the sides are not really important, right? When you're passive, you're hitting the bottom and the top. So would you go plus 50 or would you leave it as standard?
I have not done enough to give a confident answer on that. I would just say that you can do both. But in my experience with doing screw retain crowns, which I've done more where I feel comfortable enough talking about it, is that when you use different implant libraries from different companies, for some reason, they all fit differently. So if you use a tie base from Glidewell and it's a Noble Active, you mill one, and then all of a sudden you have to go to minus 40 microns to get it to fit over the tie base. But you go to Zimmer on Glidewell and the die spacer is 0. So it's a setting that you have to play around with, and it's going to vary from company to company because I think everyone speaks a different language. So that is something that you will have to dial in yourself, and it may vary. Most of them seem to be at 0, but just know that you have the option to go looser or tighter.
Perfect.
And then when it comes to metal milling, one thing that we have noticed is that HD is not better with metal. With metal bars, it's actually better to use the fine. We're finding better results. Don't go crazy with the HD mode. I would say if you're milling metal bars, stick with the fine milling mode.
From somebody that doesn't know, why would HD even be an option for bars?
It uses smaller tools, but who knows? With an update in a month or 6 months from now, maybe the HD is better. I don't know, but this is just coming from our product specialist team, specifically Big Mo. He said that fine is better right now.
Okay.
What I would say on a lab perspective is you probably don't need that much definition on the bar. That's what I at least think out loud here. But okay.
Yeah. Yeah, maybe. I mean, it could be fine for something else, maybe like telescopic bars, something like that. That maybe is like a.
That makes sense. That makes sense.
Okay, and then from here, we hit start calculation. This will calculate, and I also took a screenshot of the mill time for this bar, and this specific bar here was 2 hours and 50 minutes.
On a 20 millimeter puck or on a 13.5?
13.
Okay.
On a 13, but with a 10 millimeter bar, which this will fit into. Here's the other thing I skipped over. But when you guys see these, let's delete this one. You can see here that, let's get rid of this. Restoration. When you have any type of restoration here, the software will calculate for you the height of the restoration to tell you which puck that it will fit into. So this puck, I didn't have a 10 millimeter puck, but it's unlocked, if I rotate it like this, and now you're under 10, this technically would have fit into a 10 millimeter bar and then had a shorter milling time. So.
And just to explain the shorter milling time, this might sound obvious, but it's worth mentioning, is because you don't have to mill out like 2-3 millimeters worth of titanium to start the bar. That's why, and it's going to be cheaper for you as well, buying a thinner disc.
Yeah, and when you're doing this with zirconia, the milling time is not much faster because zirconia, it just blows through, right? Mm-hmm. With metal, you're cutting 3.5 millimeters more, which would add some time to that.
So it's time and material cost, and then also cost of the tools because you wear through your tools faster.
Correct. Okay, so now we will go to the mills, right? These jobs are calculating. These jobs can be thrown to the different mills that we have. So the first mill we're going to talk about today is the
Brian, really quick. Can you just put a random case to while you show us the mill? Just put it to calculate, and when you come back, just show us the simulation. I think it will be nice for people to at least see a simulation.
Okay, let's do the bar.
Yeah. It's going to be easier. Mm-hmm.
So let's go. Take that off. All right, so here we'll hit next. Multi-unit, simulate, HD, start. Okay, so that will calculate. And then we can show you the simulation results after.
Perfect.
All right, so for the mill, do you guys think I should switch to the other camera, or you think this one's okay?
Yeah, I think switch to the other camera in case you want to show the matron. Then you're at least you're on your cell phone already.
Okay. Now, is this better or is this better?
I think this one looks good.
This one's better? Okay. So this is the Motion 3 Air, the one that Enzo had on the package there. This is a wet dry 5-axis mill. The name air means that this does not require an external air source. There's a compressor built into the mill already, which means you can plug it into the wall and start milling without any external air source or water source. So everything is self-contained other than the electricity. The best way to connect to your computer or laptop is through an Ethernet connection. That is the most stable and functions the best. And so what we have here is a 5-axis mill, which can, where the arms are interchangeable. Show you what that looks like.
Brian, just a quick comment there, because there are a lot of words, a lot of names for different spindles. So some people will call them electric spindles, air spindles, water-cooled spindles. Can you just quickly run over what the differences are?
I don't know the difference between those.
Okay, I'll answer the question.
Okay.
Okay, so basically you have 3 types of spindles, right? When you have an air spindle, it either has an internal compressor, which I think is the case of the Motion Air, right? It has an internal compressor. And what that air is doing, it's being used to cool down the spindle, so to keep it at a low temperature, and at the same time open and close the chuck. That's that's the reason why you have compressed air inside a mill. When you have a electric spindle, the difference is it does not have this compressed air. It has some sort of different technology. Some mills have a different tool that blows air into the spindle, but it has a different type of cooling. And then you have, when you go to more industrial kind of mills, they have water-cooled spindles. Basically, you have kind of like a radiator. It's called a spindle chiller that stays on the side of the mill, pumps cool water. The water runs through the spindle, comes out warm, and it keeps on this cycle. That's the main difference. Is one better than the other? I'm not sure. It depends a lot on the kind of operation that you have.
I told you he was smart. So one of the what I just did was I basically changed out these arms. These arms are interchangeable, which I think, kind of our claim to fame was that in these mills, because these arms are interchangeable, that also makes the mills upgradable. What I mean by that is, if this mill can mill zirconia, PMMA putts out of a C-clamp or a 98 millimeter holder, and you change the arm to mill glass ceramics, and you can mill 9 at a time, you can also change the arm out and you can mill a custom titanium abutment. Okay. Now, what that means is you're buying this mill for what it can mill today. You're also buying this mill for what it can do in 5 years from now, which I don't know what that is, but know that it's already 5-axis, it's already wet, it's already dry. If there's a new software, a new material that comes out that has to change, all we have to do is make a new arm and then the machine upgrades. So Motion 3 Air, down here, can you see that?
Yes.
Okay, so down here on the bottom, you have a 5-gallon water tank. You have a suction unit for when you're milling zirconia. Zirconia is milled dry. Zirconia and wax are milled dry. Everything else is milled wet. Okay, now this cart is optional. You don't have to purchase the cart, but it is optional if you don't have counter space. If you want to put the mill on top of a counter, drill a couple holes, and put the suction unit and water tank underneath, then you can do that and save some money on the cart. Now, having this 5-gallon water tank, and if you're milling glass blocks, you might have to change your water maybe every 6 months to a year. So very low maintenance, built for higher production.
And if I can make a comment on the suction that you showed really quickly, you have the power cam EC in there?
Correct.
Okay.
Yeah.
That is a brushless motor, which is important when you are running these suctions day in and day out. You don't have to worry about pulling it out of service, changing the brushes on the motor, or changing the motor, which can be time intensive depending on what suction you have with the mill. The other thing is the bottom part is just a pull-out trash bin that collects all of the debris. If anybody deals with bags where it's the whole filter that you have to take out, this is a great change. You can just pull that bottom tray out. You've got a little trash bin in there, throw it away, and you start back up again.
Yes. Yeah. Easy to use and doesn't cost money for vacuum bags. That's the two takeaways, I would say.
Yep. And it's got a really great HEPA filter as well. So it's going to capture all that small particulate that's produced by this mill.
Okay. When it comes to cleaning, maintenance of the mill, we have these vacuum hose here. This goes into the side. Turn the suction on. You've got a brush on the tip there. You can now clean your mill, vacuum it out. All AG mills are designed on the inside to have no sharp corners. Now, this is all one piece cast iron, which means there's no possible way this can leak because everything is sitting in a cast iron little bowl down here. And again, no sharp corners, easy to vacuum, easy for the vacuum to get to these areas so that it's easier to clean. We also have inside here, which is a camera. Let's see if we can join this. So you can see here, let me share my screen. And if we go to the software here, if we go to tools, camera.
Brian, just explain to us what we're looking at right now.
So this is a camera inside the Motion 3 here. You can see as I'm moving my hand here.
Okay.
In all of our mills, we have cameras inside, and it functions very much like a Ring camera. If you guys are familiar with Ring cameras, the whole purpose of the Ring camera is not just that it's a camera, but it's important that the Ring camera records when there's movement to see what's wrong, right? So what happens with us is we have these cameras in here, but if there's ever, it's basically recording the last, I don't know, between 5 and 7 mills, depending on how big the jobs are. But if there at some point is an error message that shows up on your mill, the system will go back and record 15 seconds before the error up until the error happens. And the reason we do that is because if something goes wrong and you call the help desk can now remote in and say, hey, you know what? Open your team viewer. Let me take a look and see what happened. Instead of getting on the phone, calling the help desk, hey, I have a problem. Oh, what seems to be the problem? Well, I was milling this. Oh, what material did you use? Did you put the burrs in right? Blah, blah, blah. There's like 15, 20 minutes of all this Q&A because really the help desk is blind. They don't know, they weren't there when it happened. They don't know what you did. So really what it does is it expedites the troubleshooting process, and it also effectively will troubleshoot what happens in most cases. So from a troubleshooting perspective, that's why we put the cameras in here, but also you can also watch if I'm in the house and something is milling, I can now turn on the camera live and watch what's going on in addition to using it as a troubleshooting tool. So all of our mills have these cameras and the capability of recording. By the way, if something happens and you need a recording of something that did not air, our help desk can remote in, and they do have access to those videos. They just don't record them onto the mill. Okay, should we go to the other mill?
Yes, sir.
Sure.
All right. So we're going to jump to another room. Okay.
I forgot it's still daytime where you are.
It looks darker than it really is, but all right, great. Everyone gets to see my garage. All right, let's go this way.
There we go.
Okay, so this is the matron. This is the second mill that we were talking about, or the third one on your sheet, really. Now, the matron is everything that the Motion 3 is, except for the compressed air. So this mill does require an external air source. The amount of air that is required is 4 CFM, 4 cubic feet per minute of air at a minimum of 90 PSI. Okay, so not a ton of air, but not a very, very small amount either. So you can see here on the right, the big difference between these two mills is you have a blank changer. So it's an 8 blank changer that will load the mill it, clean it, put it back, load another job, mill it, clean it, put it back. So if it's wet milling, it will blow all the liquid off before it puts it back. And if it's milling zirconia, mills it, it will blow the zirconia dust off before it puts it back. And that's what keeps this milling chamber clean. And then you have the milling chamber here. So the size, common question, the size of this versus a Motion 3 is that the Motion 3 pretty much fits into this area here. So this mill has an additional about 15 inches wider here for the changer. So more automation in this mill than the Motion 3, because the Motion 3, although it can hold 9 blocks or 1 puck, this mill can load 8 pucks, or you can have 5 pucks. And in each puck holder, you see here, you can put, like, for example, Ceric blocks if you want to. You can do titanium abutments if you want to, 4, or you can do any combination between. So you have C-clamp, 98 millimeter in any quantities that you want that equal up to the 8 spots here. And the automation comes where when you go from wet to dry, the machine does not stop. It will keep going and mill unless there's a tool that's worn out or something like that. It will pretty much load and mill automatically. You can see here, that was the bar that I milled, that we nested earlier. So I milled that one out. And then one thing that I love talking about this mill that Enzo brought up before is the V-arm. And the one thing that separates this mill from any other mill on the market is this V-arm here. So I want you guys to think about this concept that when you're milling zirconia, glass ceramics, okay, zirconia is pretty soft, Emax is harder, but metal is even harder. And so even when we are loading these materials into these holders, there's a torque wrench that slips when you tighten it enough. But anyone who mills metal, we as users, when I'm putting this on, I really want to make sure that's tight. I don't want this thing to come loose because there is a lot of vibration when you're milling metal. Now, this spindle in this mill is twice the strength of the Motion 3. So the Motion 3 is about 700 kilowatts.
Watts.
700 watts or 0.7 kilowatts. And this one is 1.5. Okay, so almost double. So more torque, more power in this spindle. And if you look at when you're milling something and you're holding a puck like this, and the machine is pushing down and it's putting a lot of torque and a lot of pressure, you can imagine all the pressure that's on my shoulder that is putting a lot of load here, which causes movement and vibration and stress on this arm. And so what we decided on this one is, well, if you're pushing down on here and the load is heavy and there's vibration, what if I do this? If I bend my elbow and now I push here, this is not really putting much load on my shoulder at all, which allows you to push harder and have less vibration, and most importantly, mill faster, right? So you're basically what you're trying to do is mill faster, but keeping the accuracy. That is what is important with the Matron that nobody on the market has. So metal milling, you can mill titanium, you can mill chrome cobalt pucks. I don't know anything that's harder than those things in the dental market right now, but if you can mill chrome cobalt, again, you're buying this machine for what it can mill today, and in addition to what it can mill in the future. And if you can mill chrome cobalt pucks, you can pretty much mill anything. So from a potential standpoint, I would say this obviously has much more potential than the Motion 3, but again, it's also a little bit more expensive, right? So automation, potential, strength. One thing that I do like about this mill that we changed recently is that we put the vacuum here. Here's the camera for this mill. There's the camera up there. But we put the vacuum unit here, and what that means is it captures more of the dust during milling, which means less for you to clean as a user. So the dust gets collected here. The suction unit is the same down there, but a lot of these things are designed for lower maintenance for the user. Another thing that we have, which is pretty cool, is we have a tool magazine, which is held in by magnets. Okay, so you have like basically a clip. So you can quickly load up to 11 tools at a time just by snapping in with magnets. You can quickly load 11 tools at a time without having the mill sit there and not running.
And that's
And
such a
for-
nice feature.
Yes, for
You
those
don't
of you
know how
that
nice it is until you've manually had to.
So we used one. Yeah.
yeah, until you lose a couple burrs trying to like stick your hand inside
Yeah.
the mill, place it there, maybe break a burr. It happened sometimes.
I've done, yeah.
And
Yeah.
and Brian, if someone likes what the Matron offers for metal milling, but they don't care about the puck changer, they just want a single puck, the Matron core is going to provide everything identical except for the changer side, correct?
Yeah, so we have, mills in between mills, right? So to answer your question, yes, we do. Let's say somebody wants all the features of the Matron, but doesn't want to pay extra for the changer, doesn't do crazy high volume, doesn't mind or wants the metal milling without the changer with a lower price point, then there is a mill called the Matron Core, which is basically this mill without the changer, or you could call it the Motion 3 with the milling metal capability. So a lot of in between mills as well. We do offer that.
And one thing that I'd like to point out, especially when you go for metal milling machines, right? There, of course, are a bunch of other options in the market right now. But when you look at them and when you start to like really try to play with it, mess with it, operate it, you're gonna see that they are more industrial like mills. So they are more complex on the handling side. And as you can see there on the matron, this is something that I've said for a really long time. It was designed for labs from the beginning. So from labs or doctors from the beginning. It's different from a company that started in the CNC industry and then became a dental company. The AG has always been this dental company. And you see, this is a really complex mill. If you think about all the kind of things that you can do with it, custom abutments, bars, chrome cobalt, titanium, glass ceramic, zirconia, PMMA, hybrid materials, all that, and you're using the same software, you're pretty much always clicking the same buttons and you're getting reliable, quality, and fast results within the same system. I think that's what you pay for when you're buying an Amann Girrbach. You pay for this solution that is dental focused. It's not CNC focused, it's dental focused. I think that makes a lot of difference on the day-to-day of many labs and clinics.
All right. I do want to show you this, that we, in our mills, we have RFID scanners. Got some metal stuck in here. What I'm going to do is I'm going to take out tool number 10. I'm going to take it out of here and I'm going to put it in slot number 3. And I want to show you what the software does. Because when you're loading your tools into these mills to mill all these different things, in a lot of mills on the market, you have to put tools in very specific spots. And in this mill, you don't have to, because every time you close the door, it will take inventory and it knows that the tool 3 has that tool there and that slot 10 is nothing. So the mill is constantly keeping track of what's there. And same thing with the holders. If I move this holder from slot 2 to slot 3 and I close the door, the minute I close the door, it takes inventory and it knows that puck 222 has now moved into slot 3. So by the machine knowing what is in what spot means you don't have to do that, right? So there's a lot of automation in this where the machine is doing all the work for you. It's almost like having a person here load jobs for you and not stopping, going from job to job. This is the extra part of the Matron that you're paying for, is the automation and the puck changing, the higher capacity with metal milling, and then, a couple of the other features, which the vacuum unit there that I really like. And then the last thing I'll talk about here is down on the bottom, again, like the Motion 3, we have, and then you also have the suction unit. It's the same one. But one thing that we did in this unit that I really like is that we put the water pump that is normally on the inside of the milling machine, we put the pump on the outside. And the reason we did that was because if something were to happen 5-10 years down the road where the water pump breaks or goes bad, with the other mills, you would have to call a service tech. They would have to schedule someone to come in. They would have to fly in. They would have to open the panels, do a service. So it's more expensive. There's more downtime. By putting the water pump on the outside, if something were to go wrong with this water pump, we can say, hey, you know what? Overnight a water pump to you. You change these 5 hoses, connect it back up, and then you're up and running. So serviceability, just the overall experience for the customer is better, it's cheaper, and it's more efficient. There's also a water gun here, which
That's really useful.
yeah. So you can see here, after milling all that metal, there are some metal shavings in there that I will go in there with the water gun and hose them down. So other than that, it's just a milling machine.
Other than that,
Okay.
other than the last 30 minutes talking about it, it's just a milling machine.
Yeah. Anything else?
Let's just see if the simulation is done. If
Oh,
it's
let's
done,
do
I
that.
think we just cover the simulation and we hand it to Rebecca.
Okay, give me 1 second here. Switch over here.
There we go.
All right, I'm back. Share screen. Okay, so let's go back. Am I on? Okay, let's close that. Close that. So here, after this has been calculated, I'll right click.
Brian, we're stuck on the Sermo move screen.
Oh, why is that? Let me close it. See if it. Let me try on. It's stuck. Okay, there we go. Good.
Good. Yeah.
So here, this is after it's been done, calculated, it turns blue. Right click, show milling results simulation. And really you're looking for red areas or even blue. So really what you're looking for is to go into the screw seats. This is normally, I think, typical, right, Enzo? The problem areas.
Yep.
You want to make sure that this screw seat area is milling properly and it's all green. So that's good. We would go into this area here, click on that. That looks good. That looks really good there. And that one looks good. So really, in general, when you're nesting in general, I try to tell people, to make right angles, right? Always be perpendicular. If you're putting sprues, don't put a sprue this way or this way because you create a deep pocket that could introduce problems, whether it's glass ceramics or zirconia or whatever. Always try and keep right angles when you're spruing your restorations.
Yeah, and just a quick, like the gradient colors there, Brian said, you're looking for blue, you're looking for red. Just a good rule of thumb is if you're going more on the red, so yellow, orange, red, it means that it's milling more than it should have. And when it goes towards blue, it's milling less than it should have. So you have excess material. So red, it's a really huge problem because there's no way you can fix it. Blue, you can fix it by hand. That's a good rule of thumb for you to have to make sure you know what you're looking at right there.
Okay. Good?
Good, good. Okay, thank you, Brian. So now we're going to hand it off to Rebecca to talk about what everyone wants to know is how much does it cost to have everything, right? So Rebecca,
That's always the question, is how much is it going to cost? And the answer to that is that it varies based on your business. So all of these quotes can be fully customized to what you need. And we're going to talk to a lot of you after and probably hear, well, I already have my software. I already have a stain and glaze furnace, and that's fine. We can take it off. We can add, if you don't have a scanner, we can add a scanner. But just as a basic overview of available packages, we put together these three options. So if you just want to mill zirconia, we have the Motion 3 Air Dry package. If you want the option to do wet milling, there's the Motion 3 Hybrid package. And then if you want to be able to do all of the materials that Brian went over and more, we've got the Matron package. Everything that's priced out here is going to include the mill, the carts, water accessories if you need water, the suction units, sintering furnace, and a stain and glaze furnace. the software bundle for the dry package. We just have it priced with the basic ExoCAD package, which is going to give you a crown and bridge module. The other two packages are going to be the complete software suite, which gives you 14 CAD modules, and that'll allow you to do anything that you could ever want to do with these machines. And then also included in all of these is going to be 3-day training and installation packages. So when you reach out to us, we want to learn more about your business, what you're doing, what you want to be able to do. Enzo's got a really great ROI calculator. So come to us with, how many units you're doing. And we want to make sure that any of this equipment that you get from us, it's going to make you money. We do not want to sell you something that you're going to be paying off for 10 years and not see a return on. So guys, gosh, I'm sorry.
Sorry.
Yep. And then for financing, we have a few different financing offers. We've got terms up to 84 months. We also have a up to 1-year deferred payment plan available with our financing partner. So if you have any questions that you haven't already asked, just go ahead and send us a message or reach out to us. Enzo and I are going to be in Chicago at the Garland booth. Brian's going to be up in the AG room. I think we'll both have the Matron in our booths, and Brian, you'll have the Motion 3, right? In the Amann room.
We'll have everything in the room.
We'll have everything. I was talking to Justin. He said they had trucks go, like full trucks. So if you're going to be in lab day, come and see us. We'd love to show you this equipment in person and talk to you a bit more. And with that, Enzo, I will put it back to you to close this out.
Perfect. So guys, we've been here for more than an hour now. I really appreciate if you stuck with us throughout this period. I hope this added value for everyone. We try to make it at the same time simple, but with the most information we could give you guys. If you want to have a conversation like this, one-to-one, to discuss your lab, your reality, reach out to us. You probably have our numbers here or on the sides. So reach out to us. It's our job. It's our job to help you pick the right equipment to your lab, to your clinic, and help you get started. So again, thank you a lot, and hopefully see you in Chicago.
All right. Goodbye.
Guys.